Instead of manually programming every rule, we train an ML model on historical data. The model discovers patterns and uses those patterns to make predictions on the new data. And this is what we have discussed many times. So this slide basically going to present different category of the machine learning models, and each are designed to solve a specific problem. So the first is going to be the regression model. They are used when we want to predict a numerical value, for example, predicting house prices, sales revenue, or the temperature. Next is going to be the classification models. They are used when we want to assign data to predefined categories. Example may include spam detection, some sort of the disease diagnosis, and the next is going to be ensemble method. They basically improve prediction accuracy by combining multiple models. Instead of relying on the single model, they do aggregation, the strength of several models to produce better results. Next is clustering models. They are used when there is no predefined labels. They automatically discover hidden groups or the patterns within the data, such as customer segments. Next is going to be dimensionality reduction techniques. They simplify large data set by reducing the number of features while preserving the most important information. This helps with the visualization and computational efficiency. The next is going to be instance-based model. They basically make predictions by comparing new data point with a similar example seen in the past. They rely on similarity rather than learning a fixed mathematical model. Next is going to be probabilistic models. They are used probability theory to handle uncertainty and estimate the likelihood of different outcomes. And the other options we have basically gradient descent, bagging, boosting, stacking, provide optimization and model improvement strategic that helps machine learning algorithm learn more effectively. In summary, different machine learning models solve different type of problems. The choice of model is completely depends on whether the goal is prediction, classification, grouping, dimensionality reduction, similarity or similarity based learning, or the probabilistic reasoning. The next question which should come in our mind, do you really need to build these model yourself? And the answer is going to be probably not. These models are already implemented in the machine learning libraries. In industry, data scientists rarely implement linear regression or the ridge regression from scratch. Instead, everybody is going to use a pre-built implementations. The next question comes, who is offering these ML models, and are the offerings they are going to be the exactly same? But not really. Think of it like a car company. All car companies basically makes car, but each company has its own model and the strength. This slide compares four very popular machine learning libraries and the model they provide. The first is going to be Scikit-Learn. It's a general purpose ML library with many different algorithms. The next is XGBoost. XGBoost is a specialized library focused on the gradient boosting. Then you have a light GBM, fast gradient boosting library, which is developed by Microsoft. Then you have a CatBoost, gradient boosting library, which is developed by Yandex, especially good with categorical data. Why do we have different libraries? Different ML libraries basically solves different problems. So Scikit library
provides a large collection of algorithm for learning and the experimentation. Similarly, XGBoost, LightGBM, and the CatBoost, they are focused on achieving the highest prediction accuracy for structured business data. So think of it like Scikit-Learn is a complex toolbox. However, XGBoost, LightGBM, and the CatBoost, they are a specialized power tool.
Linear regression is the foundation of many regression models, but real-world data often presents challenges such as overfitting and irrelevant features. To address these problems, several variations of the linear regression has been developed, like ridge regression. This basically adds L2 regularization to reduce the impact of the large coefficients and improve model stability, while lasso regression adds L1 regularization, which can automatically remove less important feature by setting their coefficients to zero. Although these models use different techniques, they all belong to linear regression family because they predict the target variable as a linear combination of input features. This dataset contains information about houses in California, and we are going to see how those three different linear regression model will behave with the same dataset. Think of buying a house, and if we go for the data which we are going to use, that's a California house pricing. So linear regression will give you a formula like this. We are going to predict house value, and these are going to be the features based on, or maybe the input based on you are going to predict what is going to be the cost, right? And every feature is having a associated weight. And at last you see B, which is bias. So linear regression basically going to consider all the features, and it is going to assign the weight to every feature, and there will be a base value. That is how it is going to do the prediction. These weights are dynamically assigned or adjusted by the algorithm itself. So technically you can say if you're going to use a linear regression, it's going to predict house price using all the features in that particular data set. Similarly, if you go for the ridge regression, what it does, it shrinks weight but never makes them exactly zero. So what it is doing is preventing overfitting by reducing large weights. And if we go for the lasso, what it is doing, it can make unimportant feature weights exactly zero. So technically, automatically selecting only the important features. So let's take an example. If I go for the linear regression and let's say the prediction is 4.5 crore. That means we already know it. It already used 8 features. If you go for the ridge regression, it's going to predict 4.4. We used all 8 features, but we reduced some extreme weights to make the model more stable.
And then if you go for lasso, it's going to predict 4.3 because the model decided that maybe the population and average bedrooms, they're not that important. So let's try to ignore them completely. So what do you see here? The weight becomes 0 for the population and average bedroom weight is also 0. So technically, it's not going to use these two features. If you're interested, you can go for the scikit-learn.org, and here you can see the offerings, the models. And technically, the list I have shown you, you can see that all here. Then it also tells how to install. There's a user guide, how to use these models. So if we go for, let's say, Lasso, it is telling what kind of the formula, etc. they are going to use and how to import. So there's a lot of mathematics as well. So if you're interested, you can go for it. Then there's a API documentation and there are some examples as well. This is going to be the structure on your machine when you are going to install the Scikit. So this is your PC. You will have the Python installed, and then this is going to be the folder structure, which shows the different type of models basically available under the sklearn. And this is how you're going to import or going to use that particular model. So from models, you need to import the model which you want to use. I'm going to use this data, what you see on the Excel sheet, to train a model. So what is this data all about? So you can see rows and the columns, and this is data I'm going to use to predict the house price. So feature wise, you can see the first feature is the median income. This is basically the average income of the people living there. Then house age, then you have average rooms, average bedrooms, population, average occupancy, latitude, longitude, and the house value. This is going to be our target, which is basically we are going to make prediction for. And we are going to train a linear regression model, which will be trained on this data. So if you say, what is my input? The input are going to be these features. What is my output? I'm going to predict a value, which is going to be the house value based on the inputs. There is one very important concept we should know before we are going to train the model. So this Excel sheet is basically having around 15 rows. Am I going to use all the data for the training? Probably not. So what we are going to do, we randomly keep about 80% of the data which will be used for the learning purpose. Then we are going to use remaining 20% data which will be used for the testing purpose. And then we are going to ask model to predict the price for the hidden houses. If the predictions are close to the real prices, the models learned successfully. This is a basic concept here. So we'll get into the lab and see how it works. Let's do some more fun here. I'm going to upload the same file which I'm going to use throughout to ChatGPT, and I'm going to ask Can you train Scikit linear regression model based on the data and explain me what and how you have done it? So let's give it a try and see what it does. In between, I'm going to explain you as well. Since this is just the UI of the ChatGPT, does that mean I have a control on some of the box where you can run the Python and import those linear regression libraries? Probably not, because this is simple UI. So when you upload a file, what is happening? ChatGPT might be hosting some of the infrastructure, and when you upload a file, this is getting transferred and all the communication is happening over the API call. So that is something you need to keep in mind. So let's go through it and see what it has done. So it is going to use the pandas and going to load the data, what you have provided in the Excel sheet. And the Excel sheet is having the features and the description. Then it is going to separate features and the target. My features is a combination of the data. On based on that, I want to predict for my target, and my target here is what we want to predict a house value. Now it's going to split into training and the testing data. You remember we talked about 80-20 rule. So 80% data will be used for the training, 20% will be used for the validation or for the testing purpose. Then it is going to train your linear regression model, and this is kind of the mathematical formula, and I'm not going to get into this. Is enough as a network engineer you to understand this mathematics happening in the background. Then it has learned the equation, and now it's ready to make the predictions as well, and it's going to evaluate the model and it's the accuracy. It will depend what is your R2 score, what is your MAE value. So all these things comes into the picture, and this was just a sample. Similarly, you can use any of the data and do the predictions basically. Another fun slide, and what do you see here? This is installing your pandas, open PyExcel, because we are going to upload the Excel sheet. And then definitely you need the Scikit-Learn. So let's run it first. And you see here on the top is connecting to the infrastructure. Let it run. I'm going to pause this video, and once this is completed, it'll come back. The installation is completed. Now I'm going to run another cell. I mean to say the code in another cell, and what it's doing, pandas it is using to load the file, and then it is going to use the Scikit-Learn model just to train the model, and going to give you the results how the training things happens. So let's run it. I have to choose the file, and the file is here. And now we can see it's already completed, and it is giving you those R2 value, MAE value, and prediction for the first record. Same thing you can do on your VMs as well. There you need to install those Python libraries, install those pandas. So once your Python library is set up, to go for the Scikit, get the libraries, upload the file, and start making the predictions. So if we need to explain in one slide, this is what we have done. We loaded the data. We had around 15 rows, 8 features, and the target was house value. And the second step, what we have done, we splitted the data, training data, test data. 80% was used for training, 3 rows were used for the testing. And this is the mathematical formula. This model, this is how it is trained. So this is the linear regression. You have house value, and this is something, a graph which is created based on your data points. In fourth, you are making a test on based on your prediction. It is evaluating the accuracy of your model. The accuracy of model is going to be basically based on what is your R2 score, what is your RMSE, and this was the formula. More and more features you have, the formula will go bigger. And this is your feature, and this is your coefficient, and this is what is your intercept value. That is it for this video, and I will see you in the next session.